Each year, worldwide, wildfires destroy millions of acres of forest and cause billions of dollars in damage and even death. Researchers who analyzed 2 decades of U.S. records found that from 1992 to 2012, human activity was responsible for 84% of the wildfires and 44% of the area burned in the United States. So far, in 2020, there have been over 9,069 wildfires that have burned close to 4.2 million acres in California. As of November 7th, the total number of wildfire-related fatalities statewide is 31, and over 10,488 structures have been destroyed. This video will focus on those wildfires caused by overhead conductor failures and recommended solutions to prevent them. In 2019, after experiencing some of the most catastrophic wildfires in U.S. history, the California Public Utility Commission requested that all electric utilities located in the state complete a comprehensive survey with specific metrics encompassing the 5 years from 2015 to 2019. A portion of that data shows a total of 17,008 overhead conductor failures, 8,198 wire-down incidents, and 2,039 splice clamp connector failures, each with a probability of wildfire ignition. That's an average of more than 1 incident per day with an associated probability of wildfire ignition. Between 2015 and 2019, utility-ignited wildfires in California caused 115 fatalities and destroyed 25,544 structures. According to existing ignition data reporting, the total number of ignitions were 759, with nearly $32 billion in destroyed assets. The U.S. power grid, which could be considered the largest machine on Earth, was mostly built after World War II, from designs, equipment, materials, and technology that primarily date back to the 40s and 50s. Its 7,000 power plants are connected by power lines that total more than 5 million miles, all managed by 3,300 utilities serving 150 million customers, according to industry group Edison Electric Institute. The whole system is valued at $876 billion. Smart grid technology focuses on detecting or monitoring problems in the grid, while the true goal is to extend the life of aging transmission and distribution equipment. And the best method for doing so will be to prevent failures that cause ignitions from occurring in the first place. There really is a lot of truth in the old adage, an ounce of prevention is worth a pound of cure. While the focus on wildfires related to climate change is popular, another major factor related to the increase in wildfires is the fact that 80% of our electrical grid is past or approaching the end of its 40 to 70 year life cycle.
Roughly around the turn of the century, the industry began to notice an increase in reported connector failures. Initially, it seemed to have been a West Coast issue, so there was thought that it might be related to salt-laden easterly winds coming off the Pacific. However, over the course of the next few years, it became very apparent that the same issues were occurring in Illinois, Minnesota, South Dakota, pretty much everywhere. Speaking with my colleagues in the American National Standards Institute Committee on Electrical Connectors, ANSI C119.4, others in the industry were observing the same thing. With the phenomenon being so widespread, it was determined that it was something besides salt air, and it was noticeable in all types of connectors, but especially automatic splices, and we began digging into the phenomenon and learning what really goes on inside the lowly electrical connector. Up to this point, electrical connectors were considered permanent, and they were advertised as such. Beginning in the 1970s, the majority of transmission construction utilized single-die compression connections in both mid-span splices as well as compression dead ends. There has been a tremendous increase in the number of failing compression connections, due in part to this single-die design. Prior to the year 2000, mineral oil-based inhibitors were standard and would not handle the heat developed by aged connectors, particularly when they're operated at higher temperatures. Early on in our quest for knowledge, we dug into the history of connector design and the early establishment of connector standards developed to qualify connectors for use in utility applications. A principal point that stood out was operating temperatures. The original copper standards listed a 40 degrees C rise over a 30 degrees C ambient. Basically, that's a 70 degrees C maximum conductor temperature, and thus the aluminum standards began at that point. And then, based on studies by the manufacturers of ACSR conductor, that moved to 75 degrees C. ACSR was and still is rated for continuous operation, not exceeding 75 degrees C. That set off some alarm bells based on one major phenomenon: deregulation of the electric utilities, as this had led to loading lines beyond their maximum capacity, often operating in the realms of 100 degrees C or even higher. Also, demand for electricity has grown 10% over the last decade. Even though there were more energy efficient products and buildings developed than ever, and as Americans rely increasingly on digital devices, and as summers get hotter, particularly in the southern regions of the U.S., seasonal demand for air conditioning grows. The problem is only getting worse. Rather similar to everything else, increasing temperature tends to accelerate aging, and that applies to the electrical interface of connectors as well. The other major criterion applied to the design of connectors at the time was to design them for a planned service life of only 30 years. Well, these were the criteria and state of the art in the 1940s and 50s. Extensive research questioning numerous utility personnel and design engineers of connector manufacturers, and considering the hundreds of connector failures we had investigated in part, it comes to a general conclusion that utility class connectors typically provide a useful service life of 40 to 70 years.
So last fall I received a call from a large southern utility where they were planning on cutting into one of their transmission lines in order to feed a new substation. After installing brand new towers, new insulators, brand new compression dead ends, they then had their crews immediately install ClampStar dead end assemblies to permanently shunt the new compression dead ends. Now, if you think about it, it might seem a bit odd to install ClampStars immediately following the installation of new compression dead ends. But the fact is that they were connecting onto existing weathered conductor. That made them very uncomfortable, given the unpredictability of performance between connectors and weathered conductor. So they decided the best guarantee to prevent any problems in the future was to permanently protect them with ClampStar. And this point is very important to understand. Our product is specifically designed to be installed on weathered conductor. It was not designed for new construction, but specifically designed to restore the integrity of your transmission line once it's been determined that you have failing connectors. The definition being the connector is running hotter than the temperature of the conductor.
When it comes to extending the life of overhead conductors, it's pretty simple. ClampStar is an engineered mechanical and electrical shunt that significantly reduces whole span wire replacement cost when installed over a connector or on a damaged portion of conductor to function as a permanent bypass electrical connection while maintaining tension in the conductor. ClampStar eliminates replacement of overhead splices and repairs damaged bare conductors through an easy, quick, and permanent fix. ClampStar is also used to increase the performance of existing splices and other connectors, clamps, and fittings for the purpose of increasing line ampacity that may presently be limited by such devices.
It's a bit cliche, but I believe it to be extremely applicable in our case within our company. We do one thing. We restore the mechanical integrity and uprate the electrical integrity, thereby extending the life of your aging assets. This is paramount in relation to wildfire mitigation, and we have not wavered on our commitment, remaining focused on that one thing, and honestly, we do it exceptionally well.
Since 2008, Classic Connectors USA has been manufacturing engineered electrical mechanical shunts under the trade name ClampStar. Hundreds of thousands of ClampStar units have been installed to protect people and property and to prevent wildfires. To learn more, please visit ClassicConnectors.com.